Let's move to another problem where different amounts are going out or being invested somewhere, and we wanted to understand what is the maturity value of that particular amounts deposited. This is a problem relating to the future value of uneven cash flows. In the case of annuity, we are just taking a small formula and trying to find out very quickly the amount at the end of the maturity period. But in this particular case, we cannot use that particular methodology. And whenever different amounts are going to be given, we need to find out the maturity value of that individual amount or individual cash outflow value at the end of the maturity. So let us work this particular problem to make you to understand how this particular problem things can be solved. Let us understand what the problem is. He is saying that calculate the future value of money that will be received at the end of fourth year when the following investments are done at each year at the end at 9% interest. So he is saying that these are the amounts deposited and wanted to understand what is the maturity value of that particular amounts deposited at the end of this particular fourth year when the interest is going to be 9% per annum. So how do you solve this particular thing? As I said, individually we need to calculate the future value of this amount, the future value of this particular amount, the future value of this particular amount, and the future value of this particular amount. Let's do that. The future value here in this particular problem will be the present value, the first present value, first outgo, that is rupees 1000. This particular amount is going at the end of first year. So how much period this particular 1000 will be there in a bank or with outsider? So at the end of the first year, when we are depositing, the number of years this deposit is going to be there up to this particular fourth year end, we need to understand. So this is going to be first year end. So from here to here it is 1 year. From here to here it is 1 year. From here to here it is going to be 1 year. So this particular 1000 is going to be there for 3 long years. So, and the interest is going to be equivalent to 9%. So 0.09. 9% is equivalent to 0.09 because 9 divided by 100 is going to be 0.09. And N here is 3 years. So the first amount, when it goes to this particular time, the value, this particular 1000 becomes this particular value. Then coming to the second amount, it is 3000, and this is going to stay with a banker for only 2 years. Then he is also depositing 5000, and this particular amount is going to be there in a bank for 1 year. Then he is depositing 7,000 rupees at the end of the period. So there will not be any interest that is going to come. So interest is not going to come for that particular amount of 7,000 rupees. And I'm just on a uniform basis, I'm taking this particular thing also. But 1 plus 0.09 whole to the power of 0 is 1. So this particular amount remains at 7,000 rupees. So let us calculate what is the value of this particular thing. So it is rupees 1,000 into 1.09 whole to the power of 3. 1.09 whole to the power of 3. This is going to give me 1.2950. 1.2950. Then it is 3,000 into 1.09 whole to the power of 2, 1.1881 plus we have 5,000 into 1.09, and this is going to be equivalent to 7,000 into 1. So what is the value of this whole thing? So 1,000 into 1.2950, this is 1,295 plus 3,000 into 1.1881. This is going to be 3,564.30 plus 5,000 into 1.09. This is going to be 5,450 plus this is going to be 7,000. So what is the total? Let us understand. Plus 7,000. The total amount is equivalent to rupees 17,309.30. So let me repeat how we are solving this particular problem. When uneven cash outflows are going to be given, to find out the future value, we are going to individually calculate what is the future value of the first amount, future value of the second amount, the future value. As such, we know that it is nothing but present value into 1 plus I whole to the power of n. So first amount is deposited at the end of the first year. So 1,000 plus into 1 plus 0.09 whole to the power of 3. Second amount is 3,000 into 1 plus 0.09 whole to the power of 2. Like this, we are going to put the equation and to find out what is the future value of the money. Thank you.